Hello Gators, this is 3-3 rotations, day 1. I can draw and describe the rotation of a figure about a point of rotation for a given angle of rotation. Let's take a look at a GeoGebra demo in which we follow a figure around a point of rotation. Notice how the point is following around a point in a circle fashion. Let me go ahead and change the center of rotation. It is the origin. And notice how the triangle wants to go around the circle. If I change the center's location, I can even change the size of the triangle. And again, the triangle wants to go around the center of dilation. This concept of a rotation has some mathematical ideas. One, it has to have a center. Right here is the center. The pre-image, this distance from P to A, as A goes into its image position, this radius is going to be the same. So the distance from P to A and P to A prime will be the same. The way the triangle is facing will stay the same. That's what orientation is. A rotation is a rigid motion, so length and angle measures are preserved. Note that a rotation is counterclockwise for a positive angle measure. Let's take a look at these points A, B, C, and D. All of them have the same radius. This radius is going to be the same as this radius. And this radius. And this radius. So all of these points are going around the origin. Let's take a look at, now that we know their distances are the same, this has a length of 4 and a height of 4. This has 4 and up 4. So if I were to use the Pythagorean theorem, all of these distances would end up the same. Let's take a look at their slope to see how they're positioned in the coordinate plane. So we are going to go up 2 units. So this is going to be up 2 units and then over 4. So this has a slope of 1/2. This is a slope of 1/2. This one is up 4. So we're going to go up 4. But we're going to go over 2. So this is going to be -2. The fact that these two are opposite reciprocals tells me that segment OA is perpendicular to segment OB. This tells me that I have gone 90 degrees. So this rotation is a 90-degree rotation. Now let's take a look at the slope of OC. OC is right here. We're going to go up 2 and then we're going to go over 4. So this has a slope of 1/2. Now this is also the same slope as this one over here. So, and since they have the same slope, they're on the same line. So A, O, and C are all collinear. They're all in the same line, which tells me something about the rotation. So for A to go all the way to C, that had to be 180 degrees. It's on the same line. It's actually, these are, this is a collinear points. Now let's take a look at the slope of OD. Okay, so we're going to go down -4 and then go over 2, which is -2. Now, compared to the top one, this OA, segment OA, is also perpendicular to segment OD. So this is also making a right angle. And we say that this angle from A to D, remember we have to go counterclockwise. That means we have to travel a long way to turn all the way around here. This was 270 degrees. 270 degrees in order for that to be perpendicular. So all of these are turning in a multiple of 90. So here's the rule for turning multiple of 90. So if you turn this point to over here, the rule is x comma y turns into opposite of y comma x. If you want to turn 180 degrees, then you're going to change the sign of x and y. So x comma y will change to opposite of x, opposite of y. If you want to turn 270 degrees, remember this is 270 degrees, then the rule will be x comma y goes to y comma opposite of x. Please say opposite of x, opposite of y to remind you to change those signs. All right, let's go ahead and practice. We are going to turn 90 degrees. So we want to take the point 0, 1, and we want to turn it 90 degrees. So remember, we're turning counterclockwise this direction. So this is the rule we want to use. So we're going to take the y coordinate right here, and we're going to change its sign, -1, and then we're going to keep the x coordinate as the y coordinate. So this will be our new point, -1, 0. So this will be our new B prime. Now we're going to use the same rule. We're going to take our y coordinate, we're going to change its sign because that's what it says to do, change its sign, and then keep the x the same, and it's going to be our y coordinate. So this is -4 and then 1, and that'll be our C prime. And then D, again, we're going to take the y coordinate and we're going to make it negative, and then 3. So this is -2, 3, 1, 2, 3, and then this is D prime. And we'll go ahead and make our triangle like this. And this is the look of the triangle turning 90 degrees. Let's take a look at turning the triangle 180. Now, the 180 rule says to just change the sign of x and y. So B prime will be 0, comma, -1. So 0, -1, this will be our B prime. C prime will be -1, -4. -1, -4 right here, C prime. D prime will be -3, -2, -3, -2, and this is D prime. Let's go ahead and make our triangle, and this is a look of a triangle that has turned 180 degrees. So that side turned all the way over here 180 degrees. Let's take a look at turning 270 degrees. Remember, we're turning counterclockwise. The rule, this is the rule, and the rule says to take our y and make it into our x coordinate, and then change the sign of our x coordinate, make it our y coordinate. So this is B prime. We're going to take our y, we're going to move it up here, and we don't change the sign of 0. We're going to take our x coordinate, move it up, change the sign of the x coordinate, make it our y. We're going to take our y, move it up, then change the sign of our x coordinate. So 1, 0, this will be B prime. 4, -1, C prime. 2, -3, this is D prime. And this should be a look of a triangle that has moved 270 degrees from this quadrant all the way to the other quadrant. We are now going to determine the rigid transformation. So we want to know how we go from here to here. Now remember that we need to think about counterclockwise. So you need to think about going this way, counterclockwise. So this is going to travel a lot to get over here. So traveling a lot seems to me like it would be 270 degrees. Let's see if the rule got followed. So we're supposed to take our y, and we're supposed to move it to the x position and then change the sign of the x. So it looks like that happened. We're going to, we're trying to see if this rule works. We're going to use that y coordinate as our x, and there's no changing a 0. We're going to change the y coordinate, we'll make it our x coordinate, and then change the sign of the x coordinate and make it our new y coordinate. So this rule looks like it worked. So this is the 270-degree rotation rule. Let's take a look at this one. This looks like it started here and then it has to turn here. This looks like it turned 180 degrees. Let's look at our points and see if that happened. Let's see if both x and y changed their sign. Yes, both x and y changed their sign. Both x and y changed their sign. Now let's take a look. This looks like this moved not too far in our rotation, just moved a little bit. It looks like it might be a 90-degree rotation. Let's check to see if it did work. So the rule says to take our y, change the sign, and keep our x coordinate as our y. Our y is now our x coordinate. Our y is now our x coordinate. Okay, so that rule does look like it worked. And this is the end of the screencast.